Hello, class. Today we're going to be talking about similar triangles. So what I have here is a lot of information, and what I want to do is go through it with you, and then I'm going to pause the video, erase the stuff on the right, and give numbers to these triangles so that way we can go through an example, and hopefully that'll clear up any confusion you may have. Similar triangles have two properties. The first one is that the angles have the same measure. Now, I want to point this out because it's an important point. If you look at these triangles, you'll see the two arrows I have on the red angles. So that means that these two angles are equal if these two triangles are similar. And they are. I just copy and pasted one triangle. Um, so these two angles are going to be the exact same measure no matter what they are. Same goes for the green and same goes for the blue. The only difference is that these lengths are different. I hope that's obvious just based on the size. One triangle is a lot smaller than the other. So these sizes are different, but this is where the second property comes in. So the ratio of these lengths are going to be the same as long as we're talking about the ratio of the same length. So if you look at AB, that's right here on this triangle, on the bigger triangle, and XY is in the same location on the smaller triangle. So these ratio of lengths have to be, so we do two sides on the bigger triangle, AB over AC. That's going to be equal to the ratio of the same sides on this XYZ triangle. So XY over XZ. So this can be really helpful if we have one triangle where we know all the sides and one triangle where we don't. And that's where the example is going to come into play. So I'm going to pause the video now and give numbers to these triangles. Okay, so here we have an example. On the XYZ triangle, we have all three sides. But on the ABC triangle, we have two sides that we want to solve for. And these are going to be solving for lengths AB and BC. So the first thing that you want to do is try to find a ratio in which you only have one unknown. So what I mean is that your first step is not going to be to put both AB and AC and BC in a ratio because we're not going to be able to solve that. It's going to be two unknowns and two knowns, and you can't solve that with a single equation. So what we want to do is put this side AB and BC in different ratios in order to solve for each length. So the first one that I can do is AC over BC. And this is going to be an unknown AC with a known length BC, 7. And we're going to equal that to the other side. So AC is right here, so we want the side XZ. So this is going to be equal to XZ. And BC is this side over here, so we want YZ over YZ. And now we just plug in our known values. So AC is still unknown, so we're just going to write AC right here. BC, like I said, oh wait, I'm sorry, AC is known. So AC is 7 over BC. And then XZ is going to be 3, and YZ is going to be 6. Okay, so now we have a relationship that we can solve for. The way that we're going to solve this is we're going to multiply BC across to here, and then we're going to divide by 3 over 6. 3 over 6 can be simplified to 1/2. So what we're going to have is we're going to have 7 is equal to 1/2 times BC. And now what we're going to do is bring that 1/2 over by dividing it, or we can simply say we multiply both sides by 2. So when we do that, we're going to have 7 times 2, and 7 times 2 is equal to 14, which is equal to BC. Okay. So we have one of our lengths. Let's pause this, write this over to the left so that way we can make room for our next length. Okay, so now we have one of our lengths solved for, BC, and now we're just simply looking for AB. All right, so we're again going to make a ratio out of things that we know, so that way we can solve for this easily. Okay, so what we are going to do is write AC over AB, because we know AC, and we're solving for AB. Now this is going to be equal to XZ over XY. Sorry, I had to refer to my notes. XY, just to make sure I get this right. So we have AC over AB, so this side over this side, and that's going to be equivalent to XZ, this side, over XY, this side. Okay, perfect. So now we plug in what we know. AC is 7, so we have 7 over AB, and that's going to be equal to XZ, which is 3, over XY is 5. Okay, again, we're going to multiply AB onto the right and divide by 3 over 5, or multiply by 5 over 3. So what we are going to get is we have 7 is equal to 3 over 5 AB, and again you multiply or divide whichever one you want to think about it, or whichever way you'd like to think about it. So when we do that, we have 7 times 5 over 3 is equal to AB, and this is going to equal to 35 over 3. Not the prettiest fraction, but that's our solution. AB equals 35 over 3. Let me clean that up. And that is going to be it for the basis of similar triangles. Next, we're going to talk about proportionality constants of similar triangles. And tomorrow, I'll be talking about special right triangles. So we'll end this one here, and then we just have one more video on similar triangles. See you then.